In the grand cosmic ballroom, the moon is Earth's oldest and most reliable dance partner. For 4.5 billion years, it has quietly floated up there, tidally locking us and driving our oceans. But humanity has a terrible habit. Whenever we see something majestic in nature, our ape brains immediately ask, what if we blow it up? Not just a small bomb, let's talk about the ultimate human flex, gathering the entire global nuclear arsenal, around 13,000 warheads, stacking them onto a giant rocket, sending them to the moon, and pressing the big red button. Would the moon explode into a billion glowing pieces like a sci-fi blockbuster? Would it crash into Earth? Or would it just burp out a bit of dust and laugh at us? To answer this, we need to understand how absurdly tough the moon actually is. What if we nuke the moon? Let's dive into Chapter 2. To us, a nuclear bomb seems like the ultimate force of destruction. Tsar Bomba, the largest nuke ever detonated, unleashed 50 megatons of TNT. An explosion so violent it sent shockwaves 3 times around the globe. Stacking 13,000 nukes gives us a total yield of roughly 5,000 megatons. That sounds like enough power to shatter a world. Except the moon isn't a world of glass. It's a giant sphere of solid rock and metal, over 3,400 kilometers wide. The total gravitational binding energy of the moon is 10 to the 29th joules. Global nukes, only 2 times 10 to the 19th joules. That means human nuclear power is 10 billion times too weak. Detonating all our weapons on the moon is less like smashing a bowling ball with a sledgehammer and more like poking an elephant with a toothpick. So, what actually happens when the countdown reaches 0? On Earth, a nuclear blast is devastating because our atmosphere turns the energy into a superheated shockwave and a massive fireball. But the moon has no atmosphere. There is no air to carry a blast wave, no sound to roar across the craters, and no wind to sweep dust. When the thermonuclear payload detonates on the lunar surface, there is complete, eerie silence. Instead of a fireball, you get a flash of blinding radiation. X-rays and gamma rays instantly vaporizing millions of tons of lunar rock, a flash brighter than the sun for a fraction of a second, before plunging back into the void. The energy of 5,000 megatons doesn't break the moon, but it leaves a massive scar. A crater several kilometers wide and hundreds of meters deep is carved out instantly, blasting millions of tons of lunar rock upward into space. Here is where things get dangerous for Earth. On Earth, gravity and air resistance drag debris back down, but the moon's gravity is only 1/6 of Earth's. Without air resistance, blasted rock flies away at incredible speeds, exceeding the moon's escape velocity of 2.38 kilometers per second, kicked directly toward Earth. Over the following weeks, gravity weaves this ejected lunar rock into a shimmering ring surrounding Earth, much like Saturn, but far more lethal. Kessler Syndrome would trigger almost immediately. Every satellite in low Earth orbit, GPS, weather monitoring, telecommunications, would be shredded. Humanity would be permanently trapped on Earth, locked beneath a dome of hypervelocity shrapnel for centuries. Millions of lunar rocks would rain down on Earth in the most terrifyingly beautiful meteor shower in human history. Larger fragments, the size of cars or houses, would survive re-entry, causing localized kinetic impacts that could wipe out entire regional areas. Furthermore, massive amounts of lunar dust trapped in the upper atmosphere would reflect sunlight away, leading to a sudden global cooling effect, a mini nuclear winter caused by moon dust. With all this apocalyptic chaos on Earth, one massive question remains. Could the 5,000 megaton blast actually knock the moon out of its orbit? The short answer is a resounding no. To push the moon off its current path, even by a fraction of a percent, would require millions of times more energy. The moon weighs 73 million trillion metric tons. Relative to its massive orbital momentum, our entire nuclear arsenal is nothing more than a tiny nudge. The moon wouldn't care. It would simply absorb the kinetic energy and continue its silent journey around Earth, completely unfazed. This means the moon's gravitational pull on Earth's oceans remains completely intact. The ocean tides would keep rising and falling just as they always have. Earth's axial tilt remains stabilized by the moon's gravity, preventing wild climate swings that would otherwise make our seasons chaotic. So while the moon remains completely fine, life on Earth would be plunged into technological dark ages. Without satellites, global navigation systems vanish, weather forecasting degrades, and international communications fall apart. We would instantly be forced back to tools from the 19th century just to figure out where we are going. Blowing up the moon sounds like an exercise in cosmic dominance, but physics reminds us of our true scale in the universe. We often think of our nuclear weapons as world-ending forces, yet against even our small gray neighbor, they are nothing more than fireflies buzzing against a mountain. The moon would survive our foolishness effortlessly. It will continue its silent orbit around Earth for billions of years. Perhaps the real lesson isn't how dangerous our weapons are to the cosmos, but how extraordinarily fragile our own atmosphere and civilization really are. Don't forget to like, subscribe, and hit the bell icon for more existential cosmic thought experiments. Check out these other videos on the screen now, and we'll see you in the next hypothetical catastrophe. Hold on, don't click away just yet. You didn't think we would skip the hard physics in a 15-minute video, did you? Let's rewind time and zoom in on the exact microsecond our 13,000 warheads detonate to see the incredible crater mechanics. When 5,000 megatons of energy is released instantly, it creates a plasma bubble hotter than the very core of the sun. On Earth, this intense heat rises through the atmosphere, creating the iconic mushroom cloud. But in the vacuum of space, things get much weirder. Without air pressure to push back, the plasma bubble expands as a perfect sphere at hundreds of kilometers per second. The lunar regolith directly beneath the blast isn't just melted. The immense energy causes a phase transition straight from solid rock into glowing gas. This rapidly expanding volume of gas acts exactly like a massive rocket engine, creating unimaginable thrust, pushing down against the moon itself. But remember that immense binding energy we mentioned earlier? The moon's gravity and sheer mass easily fight back, absorbing the kinetic shock. Meanwhile, as that vaporized rock expands into the freezing vacuum of space, it cools rapidly, condensing into millions of microscopic glass spheres. Driven by the explosion, these tiny glass beads are launched at hypervelocity, creating a cosmic shotgun blast aimed directly at Earth's orbital path. Now let's return to the surface and talk about the crater itself. Interestingly, the impact mechanics are almost identical to a massive asteroid strike. The explosive shockwave travels straight down through the solid rock, violently compressing the lunar mantle to extraordinary, unnatural densities. But solid rock behaves a bit like rubber under extreme pressure. Once the shockwave passes, the compressed mantle rebounds violently upward. This elastic rebound is why many large impact craters on the moon, like Tycho or Copernicus, have a distinct mountain peak right in the middle. Ultimately, our 13,000 nuclear warheads would leave behind a breathtaking, permanent scar. A glowing, highly radioactive bowl 15 kilometers wide, paved entirely in smooth, dark glass. While the moon quietly admires its new radioactive scar, that cosmic shotgun blast of glass we mentioned is currently hurtling toward us. It takes a few days for the fastest pieces of debris to cross the 380,000-kilometer gap separating Earth and the moon. Because there's no air in space to slow them down or keep them together, the microtectites and rock fragments spread out into a massive, expanding swarm. As this swarm reaches Earth, it doesn't just hit one spot. Earth's gravity pulls it in, wrapping the incoming debris entirely around the planet. This brings the deadly swarm right into the most crowded neighborhood in space, low Earth orbit, home to thousands of our satellites. In orbit, speed is everything. A tiny glass bead, traveling at 10 kilometers per second, carries the kinetic energy of a bowling ball moving at supersonic speed. When one of these tiny, beautiful glass beads strikes a multi-million-dollar communications satellite, it doesn't just poke a hole, it vaporizes on impact, sending a shockwave that shatters the spacecraft into thousands of new, deadly shrapnel pieces. This is the true nightmare of the Kessler Syndrome. One destroyed satellite creates a cloud of debris that immediately destroys two more. 2 become 4, 4 become 8. Within hours, a cascading chain reaction rips through our entire orbital infrastructure, tearing everything to shreds. The shimmering ring around Earth we saw earlier isn't just moon rock anymore. It's heavily mixed with the pulverized, sparking remains of our modern technology. We have effectively built a prison wall made of hypervelocity bullets, cutting ourselves off from the rest of the universe for centuries. But what about the massive amount of debris that doesn't stay in orbit? The vast majority gets pulled straight down into Earth's atmosphere. Hitting the thick air at cosmic speeds, the extreme friction instantly superheats the air around the rocks, turning them into blazing plasma trails. From the ground, the sky doesn't just sparkle. It looks like the entire heavens have caught fire in a silent, beautiful, and utterly terrifying display. Most of the smaller pieces burn up harmlessly in the upper atmosphere. But remember, we blew up a mountain's worth of solid rock. Larger fragments, the size of cars or small houses, would easily survive re-entry and strike the ground at hypervelocity. They wouldn't cause a dinosaur-level extinction event, but they carry the kinetic force of tactical nuclear weapons. These localized kinetic impacts would strike randomly across the globe, wiping out entire cities and critical infrastructure in a flash. The sheer heat from thousands of atmospheric entries and ground impacts would trigger massive, uncontrollable wildfires on every continent. But the fires and the falling rocks are just the opening act. Remember those billions of microscopic glass beads we mentioned? They don't fall as quickly. Instead, a massive blanket of lunar dust becomes trapped in Earth's stratosphere. This shiny glass layer acts like a global mirror, aggressively reflecting the sun's warm rays back into deep space. Without sunlight, the planet's thermostat breaks. Global temperatures would plummet drastically within a matter of weeks. Welcome to a mini nuclear winter, caused not by radioactive soot from our own cities, but by pulverized moon dust. As the freeze sets in and the sky goes dark, photosynthesis grinds to a halt. Crops fail, and global agriculture collapses entirely. The food chain breaks down from the bottom up. Without plants, herbivores starve, followed quickly by the carnivores, leading to worldwide famine. And let's not forget, humanity is trying to survive this sudden, brutal ice age with absolutely zero modern technology. Because our satellites were shredded, there is no GPS to coordinate relief, no weather tracking to predict storms, and no global communications to call for help. Earth becomes a freezing, isolated, and primitive world, trapped beneath a beautiful but deadly ring. We wouldn't have just destroyed the moon, we would have destroyed our own future. But before you start building your underground doomsday bunker, let's pause the simulation. The truth is, this entire apocalyptic scenario assumes one very important thing, that our weapons are actually strong enough to shatter a large chunk of the moon. We love to flatter ourselves with the destructive power of our nuclear arsenal, imagining we are conquerors of nature. Yes, 13,000 warheads is absolutely enough to wipe out human civilization multiple times over. We could easily scorch our own delicate atmosphere, poison our oceans, and end biological life on Earth as we know it. But to the grand scale of the cosmos, our ultimate doomsday weapons are basically a tiny, insignificant firecracker. For billions of years, the moon has survived direct asteroid impacts millions of times more powerful than all our nukes combined. Just look at the South Pole Aitken Basin, a colossal impact crater on the far side of the moon spanning over 2,500 kilometers. The ancient asteroid that caused it hit with unimaginable kinetic energy. And it didn't shatter the moon. It barely even made it flinch. So, if humanity actually managed to unite, stack every single nuke we have onto a rocket, and launch it at the moon, we wouldn't get a spectacular sci-fi explosion. We wouldn't get a deadly ring of hypervelocity debris trapping us on Earth. Instead, we would just get a small, silent flash of radiation on the gray surface,
That's it?
lasting only a fraction of a second. It would leave a new, slightly radioactive crater, completely indistinguishable from the millions of other craters already up there. The moon would continue its orbit exactly as it always has, completely indifferent to humanity's foolish attempt at cosmic dominance. And Earth? Earth would remain perfectly fine. The tides would rise, the sun would shine, and honestly, we would just be out of nuclear weapons. Which, if you think about it, is probably the best possible outcome for our species. We spend so much time worrying about our own destructive power, fearing that we might break the world, that we forget how resilient and violent the universe actually is. Black holes collide, supernovas detonate, and whole galaxies tear each other apart.
When we look
Against
at the
that
cosmic
infinite
timeline,
backdrop,
the entire
humanity
span
is
of
just a
human history
brief,
is just
noisy
this
spark
tiny,
in the dark.
vibrating electric
The
spark
cosmos
right
doesn't
here.
care about our borders or our bombs. But that doesn't mean we don't matter. In fact, our cosmic insignificance is exactly what makes our existence so incredibly precious. We are, as far as we know, the only part of the universe that can look up at the moon and wonder, what would happen if we blew it up? So let's keep our nukes dismantled, our atmosphere clean, and our cosmic curiosity alive. If you want to support our existential thought experiments, you don't need to detonate anything. Just visit our shop. We have incredibly high-quality posters, shiny enamel pins, and plushies that are scientifically guaranteed not to cause a nuclear winter. A huge thank you to our Patreon supporters. You are the absolute best, and you make these animations possible. Don't forget to like, subscribe, and hit that bell icon so you never miss an upload. Check out these other videos on the screen now. They're scientifically proven to cure boredom. As always, stay curious, and we'll see you next time.